Hi, 8th grade. All right, we are back doing lesson 3, session 4. We are working with a sequence of transformations and congruence. Basically, prove that it's congruent by showing me a sequence of transformations. Kind of like what we did just the last lesson. Okay? All right, let's go to work on the example. Figure N has vertices at -5, 3, 0, 3, -3, 1, and 5, -1. Figure N triple prime, has these vertices. Describe a sequence of 3 transformations that you can perform on figure N to show that figure N is congruent to figure N triple prime. Okay, so first, what do you think happened from N to N prime? Well, that one's pretty easy. It looks like it just reflected across the Y. So we're going to say reflect okay, reflected across the y-axis. Now, how do you think N prime got to N double prime? To me, that looks like a rotation of 90 degrees. If I were to take this and just rotate it, it would land there. Okay, so I'm going to say rotate 90 degrees, and that looks like it's clockwise. When I say about the origin, what that means is the origin was the center of rotation. Okay, and then how did I get from N double prime to N triple prime? It looks like it moved over, let me go from here to here. 1, 2, 3. So 3 units to the right. Okay, there we go. Number 1, figure W is congruent to figure W double prime. What sequence of transformations can you use to show this? So basically we got to go in there and we got to show what happened to figure W prime. I mean, we got W and W double prime, but where's W prime? So how do you guys think it got from here to here? I'm seeing that we could rotate this way 90 degrees. If we rotated this way 90 degrees, it'd be, this corner would then be here. This corner would then be around here. Nope, sorry, up here. Let me erase that. Right here. This corner goes 1, 2, 3 below this corner, so it'd be like right here. And this corner is 1 below it, 2 below it, and then 2 over. So like this. Okay. So if I were to rotate first, W 90 degrees, counter, clockwise, it would look like this. That'd be W prime. And then we would take W prime and translate it. Let's see, how many does it go from here to here? 1, 2, 3, 4, 5. 5 units. Oops. To the right. Awesome. Number 2. Let me scroll my paper. Triangle PQR has vertices. This. Triangle PQR is reflected across the x-axis, and then it's rotated 180 degrees around the origin. What are the coordinates of PQR double prime? Okay, so we got to kind of remember those weird rules that we learned. We didn't really learn the rules all too well for reflections or rotations. We learned them really well for translations. So let's think about this. I'm going to just draw me a little sketchy sketch, okay? It's not the best, don't get me wrong. I wish I could have grid paper on here. -4, 4. Q is -2, 3. And then R is -5 up 2. Okay, bear with me. I know it's not the best. It's reflected across the x-axis. Okay, so that means all my points are going to go down in here now. So P was -4, 4, which means this will be down 4 and still over 4. 1, 2, 3, 4. So it's going to be right here. That's -4, comma, -4. Q is -2 up 3, so that means it's going to go back to down 3. Oops, I'm not going to write Q. We know that's Q. I'm just going to write the coordinates, which what we said was -2, comma, -3. And then R was over 5 up 2, so now it's going to be over 5 down 2. Okay, so there is my little guy reflected. Then it says it is rotated 180 degrees, so I know it's going to be in the quadrant opposite of that, around the origin, so it's going to be up in here. What are the coordinates of P, Q, R? Okay, we did learn some rules about if you're rotating 180 degrees, you could just switch the coordinates. So I'm thinking for a second. This would move up to here, so that'd be 2, 3. And that was Q prime. And then this is -4, -4, so let's try 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. Looks like Q should be up a lot higher, doesn't it? Yeah, let's not do this. Okay. I gotta think for a second. I think R, which is this guy, I think R is gonna be matched up at the same place where R is up here. So it's still gonna be over here, and R, wait, not that far over. R is -5, 2, so 1, 2, 3, 4, 5. It's still gonna be 5, 2. We were on the right track, guys. I just started second guessing myself. So this is gonna be 5, 2. You guys, I think what's gonna happen is all of these are going to kind of stay the same, but the difference is that they're gonna kind of like change their signs. So let's see what Q is gonna be. Q should be 2, 3. It's like this. 2, 3. And then this should be 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. Hey guys, I believe we did this right. It looks good. Okay. So the rules about rotations, if you're rotating 180 degrees, you just switch their signs. Okay, so everything was negative down here, now it's all positive because it's in the positive, comma, positive coordinate. So, man, that was a lot of work. We're gonna say P double prime is, let's see, this was Q. P should be 4, 4. And then we got Q double prime is 2, 3. And then we have R double prime, which was 5, 2. All right, number 3. Which graph shows the image, remember the copy, of the triangle after a translation 6 units to the left, followed by a reflection across the y-axis? So if we went 6 to the left, we'd go 1, 2, 3, 4, 5, 6. So it would look like 1, 2, 3, it'd look like that. And then if I reflected it across the y, which is down here, it would look something like that. Okay, so it looks like it's down, over 5, down 1 for this point, so let's just check that. B automatically already looks correct to me. It's over 5, down 1. The rest of these are all in the different positions, so we're gonna go with B. Kamal chose A. How do you think he got A? Holy smokes, he's way over. He didn't just like move over 6 units, he went over a ton. Oh, you know what it looks like to me? It looks like he reflected it across the x-axis first. If he did that, it would look like this. And then do you think he moved it over 6 units? 1, 2, 3, 4, 5, 6. Yep, that's what he did. Okay, so he reflected it over the x-axis, then translated six units to, whoops, keep doing that, to the left. Poor Kamal, he was just extremely confused. You have to do it in the order of events. If you don't do it in the order that they tell you to do, you're gonna get a wrong answer. Okay, number 4. Reflect the figure at the right across the y-axis. Then, rotate the image 180 degrees around the origin. Draw the image after each of these transformations. What single transformation could you perform on the figure to get that same final image? Okay, so first what are we doing? We are reflecting it across the y? Okay. So let's see here. This is over 1, up 3, so this one would be over 1, down 3. This one is over 4, up 1. So we'd go over 4, up 1, 1. This guy is over 3, up 2. Over 3, up, down 2. Ooh, and then this guy way up there is 5, 5. Okay, so now let's go ahead and draw that little sucker. Something is not right. Okay. Connecting the dots is hard sometimes, okay? Don't judge me. Okay, that looks a lot better. And then we rotate it 180 degrees, so it's just gonna whoosh, go right up here, okay? And it's going to look something like this. And still at 5, 5, okay. Remember, it's the same coordinates, it's just they switch their signs. Right there, right there. Okay, let's see how we did. Okay. Well, that one's pretty simple. What does it look like? Like if I would have completely have skipped this whole step, doesn't it look like it just reflected across the y? Yeah, I could have done that just by reflecting across the y. So that's what they're asking. They said, after you draw this, what single transformation could we have performed to get that same image? We could have reflected the figure across the y-axis. Okay, number 5. ABC, triangle ABC, and triangle DEF are congruent. Which sequence of transformations could we perform on these to show this? Select all that apply. Okay, so could I rotate ABC 180 degrees around the origin? Well, if I were to do that, you guys, it would look something like this. Not like that. Okay, so A doesn't work. Let's erase that. How about B? Reflect ABC across the X. Okay, so if I reflected it across the X, it'd look something like this. And all the way to 5. Then what does it say? Then rotate the image 90 degrees counterclockwise about the origin. So if I were to do that 90 degrees counterclockwise, it'd go that way. And it looks like this 5, 5 would land still at this 5, 5, 2 would hit 5, 2. Remember, they just switched places. So yes, I believe that would land perfectly right there. So B is good. Okay, C. Rotate ABC 90 degrees clockwise. Okay, so clockwise is this way. So if I were to rotate this 90 degrees clockwise, it looks something like this. And then reflect it across the X. Well, let's see here. If I reflected that across the X, it looks like it'd be the same shape in the same spot. Maybe I did this, maybe it's gotta go like that for the rotation, because this is up 2, and this would have to be up 2. Okay, so then if I reflected that over here, it would land perfectly on top of each other. We like C. Okay, D, rotate ABC 90 degrees counterclockwise, so it'd go this way around the origin. Okay, I'm not even going to draw that, because if I rotate it 90 degrees counterclockwise, it's going to land in this quadrant, not even in the right quadrant. Okay, so D doesn't work. Okay. Oh wait, I didn't read that all the way. Then rotate it 90 degrees counterclockwise around the origin again. Flip, flip. No, because then it would look like this. It'd look like that. Okay. Okay, D is for sure wrong. Okay. E, reflect ABC across the y-axis. Okay, so it'd be over here like this. If I reflected it across the y. Then rotate the image 90 degrees clockwise. So then if I rotated it, click, 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 this would land here. This guy would land down here. This guy would land right there. Yep, that looks good to me. E works. Okay, number 6. Oh, we still have a lot. G and G triple prime are congruent. Which sequence of transformations can you perform to show this? Okay, only one of these will work. Can I reflect G across the x-axis, then translate it 3 units up? If I were to reflect this, it would look like this. And then if I were to translate that 6 units up, no way would that land on G triple prime. A is out of here. How about B? Reflect figure G across the x-axis. Okay. Wait, I did A wrong, didn't I? I reflected it across the y-axis. So it says reflect it across the x-axis and then move it. So, okay, even if I reflected this over here and then I moved it 6 units up, it would still not land on the right spot. Okay, so A is for sure wrong. Oops, I didn't do that. B says reflect G across the x-axis. Okay, so it would be down here, like what we were just talking about. Oops, I'm doing it wrong again, aren't I? It goes like this. Okay, so if I reflected it across the x, translated it 6 units to the left, 1, 2, 3, 4, 5, 6. Mine's a little bit off, isn't it? It should be like way further out here, huh? Okay, and then moved it 5 units up. 1, 2, 3, 4, 5. Oh, look, you guys, it would. If I were to slide this little sucker up there, it would land perfectly on there. So B works. I'm not even going to worry about C and D. Okay, number 7. Oh, this is easy. It's just going to ask us which quadrant it's in. Okay, so we're just going to kind of like sketch this. I'm not going to make it perfect, okay? Triangle XYZ is in quadrant 1. We don't have any coordinates. It is rotated 90 degrees counterclockwise, so it's going to go that way. So it's going to be in this one now. And then it's going to reflect across the Y, so it's going to go back over here, but all rotated. Then it's going to get translated 5 units to the right, so it's going to go this way, couple. Which quadrant is it in? It's in quadrant 1 still. quadrant. How do you know? Because I drew a picture. Number 8, figure R is congruent to figure R triple prime. Describe a sequence of 3 transformations we could perform on figure R to get R prime, or R triple prime. Okay, so let's think. I can see that it definitely looks like it rotated. I'm gonna say it rotated 90 degrees clockwise. If it rotated 90 degrees clockwise, it would be up in this quadrant. And it would look something like this. So this point is at 7 down, 5 over. So we'd go 7 over, 5 up. Or maybe we'd go 7 up and 5 over. 4, 5 over, like that. Okay, this point looks like it is 6 over and then 3 down. So I'd go 3 over and 6. Okay, bear with me, we'll get this. This guy's only 1 over from him. This guy is 5 over and 4. So I'm gonna go over 4 up 5. I think we're on the right track, you guys. I know it looks a little sketch at the moment, but I think we got this. This should go straight down like that. Erase that guy. So it might go up 1. This is 2, 2, so it should be 2, 2. And this is down 3, 1, 2, 3. Then it connects. Oh boy. That's a weird shape, but I believe we have it right. Okay, so we rotated. "90 degrees clockwise." Then what? Then we had a translation of 8 units to the right, maybe? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7. So 8 over, 7 down. Okay. What I basically did is I took the point right here and I want to see how many I could go over and then down to make it line up with this point. So rotated 90 degrees clockwise, translated 8 units to the right, then translated 7 units down. All right, there you go. There are 3 steps on how we did it. The hardest of all these was definitely the rotation. Okay, last one, number 9. Describe 2 ways that you could transform triangle S to show that it's congruent to triangle T. So let's see here. It definitely looks like it got a nice little rotation it put in there. Okay, I would say 90 degrees counterclockwise, so S would go 90 degrees this way. If it went 90 degrees this way, it would just kind of look like a okay, so if I were to rotate this 90 degrees, I'm rotating my iPad and I think that's super helpful. Like, you guys can try that. So S, this is gonna stay. Oh, unless it was about the origin. If I were to rotate it 90 degrees based on this point, it would look like this. 1, 2, 3, 4. 1, 2. That doesn't look right. It looks like it needs to go a little bit longer, doesn't it? So So maybe I don't want it to rotate at point S. If it rotated 90 degrees on point S, it would look like this. There we go. Okay, that makes more sense. If I rotate this 90 degrees about, sorry, I keep saying point S. It's not point S. S is the shape. It's point, whatever that is, on the y-axis. So if I say rotate 90 degrees on the point that's touching the y-axis, and then what we could do is we could say we translate it, go from this point to this point. 1, 2, 3, 4. 4 units to the left, and then 1 unit down. I mean, that's kind of like a gross way of doing it. We could have done it a few other ways, I'm sure. But hey, it works. So we'll say, first thing we did was rotate 90 degrees about the point on the y axis. That's kind of important. We have to put that we're rotating on this point, okay? After we rotated it, then we've got to move it 4 units left and then 1 unit down. Okay. Holy smokes, you guys, there was a lot of questions on this lesson. Go ahead and scan 64, and then you're going to upload that to the Google Classroom. We are going to go over this session in class because there's no green pages, and then we will review for a quiz, and we'll have a quiz on lesson 3. All right, guys, let me know if you have any questions at all. Bye.